For the use I get out of a car, I want one that won't cost too much to run. That's more important to me, you know, than the looks of a car.
I like the way the sound of the sedan, but I need a wagon because that thing could be full of samples. It has to be full of merchandise at times. I've got a dog and 3 kids. It could be full of that.
I don't know. I believe status is a frame of mind. I get the same quality and luxury in a car of this size as I would if I would have spent thousands of dollars more.
Where does the customer's new car begin? It begins in the minds of people, our first resource. Sometimes they ask us. Sometimes they tell us, with words, a shrug, a smile, a frown. They tell us by what they buy, or don't buy. But however they tell us, we listen. It begins, too, in our scientific research laboratories. Gateway to the unknown. In the structure of particles often smaller than the atom, all searching out the structural secrets of solids in order to make them stronger, more durable, to make them do more, to produce better materials, to make stronger, better performing components. As it begins with inquisitive minds, free to search for the unknown, so does it begin with enormous physical capabilities, the might and muscle, the brute strength necessary to make the kinds of cars that people want. It begins with an ever-growing investment in factories, machines, facilities, resources, equipment, materials, supplies. It begins with a corporate conscience, a determination to reduce industrial waste pollutants, exploring the limits of existing technology. $24 million spent on pollution control alone in this one plant. Enough to build an entire assembly plant a few years ago. It begins with new processes, such as the electrocoat paint process, in which the body is charged with electricity to draw the paint like a magnet and literally plate it with protection against rust. Such as new power wrenches, eliminating the problems of too much torque, which can strip threads or break bolts, or too little torque, which can leave them loose, to rattle or fall off. Such as a new experimental powder paint process that may someday eliminate the hydrocarbon pollutants of paint solvents. It begins with safety research. From which come ideas for things like the bumpers that will meet government safety requirements and also improve sheet metal protection. Safety that evolves from a continuing program of crashing test vehicles. An average of 2 cars crashed each day. It begins with the most important investment of all. People. People. Almost 500,000 of them around the world. The people who make the system work. Yet all this investment, all the resources are there for but one purpose. To build cars of superior quality at competitive prices. A car begins at all these places. Years from now, what kind of automobiles will these people want? The countdown starts. We ask, and we listen. 20 million pieces of information about people. What are they doing? Where are they going? Where are they living? What are they buying? Why do they buy? How many different types of people are attracted to the same type car? What are the new patterns, priorities, habits? How are their values changing? Billions of pieces of information stored in computer tape memory banks. Feedback from our sales records. From our studies of trends. All this information about tastes and needs is fed into product planning. What areas of the car need improving? Performance, design, manufacturing cost, interior room, more convenience. Which improvement is most important? Each objective has a price tag, and we know we can't have them all. There are always 2 or 3 years of specific car development projects going on. Preliminary product plans are formulated for models 5 or more years away from the market. At the Design Center, the free creative mind experiments with shapes that are pleasing to the eye, giving the car its form and its dimension. The designer works with product planning to translate objectives into specific car requirements, which we call hard points.
These hard points give us the actual dimensions that we work to, such as wheelbase, overall length, overhangs, front and rear tread. The designers then start their sketch programs based on the hard point information.
Sketches, dreams. Give design flair to the hard point numbers. The car has to fit around people. A plastic average man helps determine the inside dimensions. There are instrument panels to design, door panels, seats, and trim materials. Hundreds of ideas are distilled. Some of these become full-size clay models. But the choice must come down to one. In today's design studio, each clay model curve and contour is read with exacting technology, translated into numerical formulas and equations, stored in a computer memory bank for precision design and engineering use. Final design changes, final approvals, design sign-off. This is what the car will look like. At the same time that design has been giving the car its form, engineering, guided by those same hard points, has been designing and testing to create the right chassis, engine, powertrain, component parts, and the body that will enclose all these things and enclose the people who will ride inside it. Engine development. All kinds of engines for the needs and wants of all kinds of people. A separate team for developing crankshafts. Another for timing. One for carburation, cooling, ignition. Separately and together, the parts and the engine are tested. And tested. And tested. Millions of test miles a year on test track and road. Pass the power along to the rear wheels. Match the engine with the right transmission, driveline, and axle. Give it resistance. Make it work. Test until you're sure. There must be other things. Things that start the car. Keep it warm in winter, cool in summer. Light its instrument panel, its way on the road. Clean its windshield. Lower and raise its windows. And fill it with music or the latest news. And the entire system has to work every time. All the switches, wires, fuses, connectors, motors, lights. Every time, in every car we make. The dual paths of engineering and design draw closer together now. Molds, experimental tools, and dies have yielded the first handmade parts. For the first time, still more than a year from production, all the elements that have been developed separately are put together as a single composite unit. The engineering prototype, a hand-assembled first edition. And destined for what? To be abused. To be tested far beyond the limits of normal driving. Raced. Spun around curves. To be run over chuck holes. Cobblestones, curbings, and washboard sine wave tests. To be stopped on a dime. Drenched. Run through hurricanes. Choked with heat and dust. Frozen. To be bounced and jounced on machines that bring the bumps and chuck holes of the road right into the laboratory. As the time for Job 1 draws closer, all the elements come together for their initial tryout in the pilot plant. For fit, appearance, and manufacturing feasibility. Every body style of every car gets this treatment. Every tool, jig, and fixture that will be used in assembling each car has to work here first. Everything is tried out here, so we can uncover problems and make corrections before assembly starts. The materials that will be used to make the car in quantity are already converging on Dearborn and the many other manufacturing centers. The giant heartbeat begins with a thunder and din that will eventually change raw material into an automobile. Pellets of iron ore for the hungry furnaces. Iron for engine blocks. Silica sand and other materials are fed into furnaces to melt into glass. Glass, A continuous strip, 8 feet wide. 5,000 miles of it a year. Enough to reach across the United States and back again. Vinyl for door and trim panels, roof coverings, upholstery. 50 million square yards of it a year. Enough to build a tent a mile wide and more than 16 miles long. Steel for frames and panels. Nearly 5.5 million tons a year. A ribbon 4 feet wide that would stretch almost halfway to the moon. Plastics. Plastics for more than 700 different automotive parts. Assembly has already begun on component parts that will be shipped to assembly plants, ready to be programmed into the final car building process. Carburetors, alternators, distributors, small motors, brake system components. The car's power plant, the classic V8, begins its precision assembly. Cylinders are honed. Working parts are assembled. 52 million V8s since 1932. Manufactured, built, and tested, and programmed into the exacting precision of the automotive assembly process. Every day, more than 50,000 different kinds of production parts flow into the 20 assembly plants. Every day, as many as 80 boxcars of parts arrive at each plant. Each time an order is written, this action is set into motion. A multitude of items are programmed for production, each component coded by computer and tagged with its own identification sheet, showing its ultimate destination as part of one particular car. One of the great wonders of modern industry, the automotive assembly plant, living, breathing, working. The body build-up begins. The welder's gun will be applied to more than 4,500 spot welds in this car to hold the body secure and protect against squeaks or rattles, against the strains and stresses of a long driving life. Smooth out the joints with solder so they become invisible. The trained eye probes for possible flaws. Coat it with primer. Inspect. Add 3 coats of enamel. The final color. Hand truck the painted bodies to their scheduled position on the trim line. Half of them ticketed for vinyl roofs. All ticketed for their own instrument panel, wiring, heater, radio, and other components. Add the sealers, deadeners, and insulation to protect the car's inherent quiet. Cover it with a headliner. Enclose it all in glass with such skill that as many as 15,000 windshields have been installed consecutively without breakage. The frames come down their own line. Take on their individual suspension systems. The engines get their final dress-up and join the frames. Frame and body become a single unit. Give it maneuverability. Give it fenders and hood and wheels to roll on. Give it a finished interior and eyes for the dark. Test the fit of windows, doors, and deck lid in this simulated downpour. Here on the final line, 1 out of every 10 men is an inspector. There's a lot to check out. Everything that moves, or latches, or turns, or swivels, or runs, or lights up, or does anything. Job 1. The car has come to life. 15,000 separate parts joined together to form a unique automobile. 19 hours after the first welding guns went into action, more than 5 years from the time the first opinions and impressions were gathered from the people the car was made for. For the next 52 weeks, this year's model will roll out here in an unbelievable variety. In a spectrum so broad, it will be possible to stand beside the final assembly line 8 hours a day for a year and never see 2 exactly alike. It's the best we've ever made. The finest possible product of all our resources, all our best efforts. Yet we continue the never-ending search for improvement, sorting through the public tastes and requirements that continue to change, devising more new methods and procedures, shaping the models for next year, and the next, and the next, and the next.